Pankaj Gupta from Venture Partners. We are a deep tech accelerator based in Singapore. We have approximately 56 startups in our portfolio. All of these are AI, ML, blockchain, IoT, robotics, AR, VR kind of startups from different parts of the world, stages, and sectors. SkillReal is one of our portfolio startup, which is actually bringing transformation and innovation in the automotive and aerospace and defense manufacturing space. And that's why we have this interesting topic, interesting panel today to talk about all these innovations that are happening in the R&D industry. Now, I will pass it on to Shai, who is the CEO of SkillReal, so that he can talk about SkillReal for a few minutes, and then we can get into the panel discussion. Shai, over to you.
Good afternoon, good evening for all. So I'm Shai Newman, I'm the CEO and founder of SkillReal. And just a few words about us. SkillReal develops the next generation AR technology, AR and measurement technologies. And we have our solution selected by Siemens, and it's sold worldwide, and it's already in use by leading A&D companies like BAE Systems, IAI, and several others. And we are already generating good value by enabling live AR work instructions with inspection of every assembly step. So we reduce drastically the number of mistakes and also shorten the ramp-up time for new employees and so on. We'll be glad to share with you more information later. You can visit our site, you can contact me. And I think from now, let's start with our panel. And I suggest that we will start that each panelist will just present himself. We can start according to any order you want.
Probably we can start with General Levy.
Yes.
Okay, well, that's I'll presume that's only because I'm the top of the Hollywood Squares boxes on the screen. So first of all, good morning, good evening, good night, good day, wherever you are. It's amazing that we can put these kinds of programs together and have a chance to collaborate internationally. And that's really the value of these sorts of events is all of us are way smarter than just one or two of us. And so it's a great opportunity to be with you. I'm Lee Levy, retired Air Force General Officer, spent 34 years in the United States Air Force. Before that, I was a commercial airline pilot. In the Air Force, I did a variety of things with operations, logistics, sustainment. In my last couple of jobs, I was responsible for all of the logistics, all of the maintenance, all of the global supply chains, all of the software development, nuclear weapons sustainment, et cetera, for most of our Air Force, what we now know as our U.S. Space Force, parts of NASA, and then other parts of not only our sister military services, but for our 63 foreign military sales countries who have bought stuff from our Air Force. Retired a few years ago after a absolutely thrilling career, getting to lead America's sons and daughters and work with our allies and coalition partners. Started my own company. I'm also on the NASA, spent the past 3 years on the NASA Advisory Council, which is sort of the NASA Board of Directors, if you will. On the Oklahoma Governor's Aerospace Council. I work on the boards of directors of several companies. I do consulting. I have a background in national and international security, supply chains, logistics, advanced manufacturing, and a whole bunch of other things. And I just do whatever looks like fun. After all that time in the military, I try to do fun things and spend my time with people such as y'all that look interesting and who hopefully we can collaborate with to make a better society for all of us. So with that, thanks again for organizing this and for letting me be a part, and I'll pass it on to the next panelist.
Really appreciate it, General Levy. Really appreciate it. Sapar.
Hello, everybody. My name is Sapar Satay. I'm Commercial Director of Head Aerospace for CIS countries and East Europe. So Head Aerospace Group, it's a Chinese company with headquarters in Beijing. And this company has two subsidiary, let's say, portfolio companies. One is France, Head Technology France, to whom I belong. I'm currently based in London, UK. And the second company is Head Aerospace Netherlands. So our company is new space emerging company. So we have like two business domains. One business domain is we are commercializing Earth observation data from almost all Chinese satellites, and we have also our own communication satellite constellation. We operate and provide communication satellite services, including satellite IoT services. So my background is I used to work for more than 10 years in aerospace industry. The major part of my career passed in Kazakhstan. So I'm originally from Kazakhstan, and I worked for Kazakh space industry, and I used to work also for German space industry. So today, I would like to thank you for inviting me to this interesting panel session and to get to know the other experts. And I'll do my best to share my top level knowledge, specifically in satellite industry, according to the agenda. Thank you.
Thanks a lot, Sapar. Really appreciate your time. Let me move on to Professor Srinivasan from India.
Hi, Pankaj. Good morning and good evening to all the panelists. So I extend my warm greetings to all the panelists, and as well, I extend my gratitude and thanks to Pankaj for making me a part of this event. And I work for Orvi College of Engineering, one of the premier institution and top 100 in one of the top 100 institution in India. And I work for the Aerospace Department. Basically, I started my career as a contract engineer in National Aerospace Laboratories Propulsion Division, NAL SCSIR organization. Then afterwards, I switched on to the academics as a professor. So that's a small list about me.
Thanks a lot, Professor. Let me move on to Zvika from Siemens.
Yes, thank you, Pankaj. Can you hear me?
Yep, very well. Please go ahead.
Okay. So my name is Tzvi Weissman, or I go with Zvika. My name is Zvika Weissman. I work for Siemens Digital Industry Software. We are a software company, part of the portfolio of Siemens. And within this software company, I work in the digital manufacturing product line. So it's basically a group of people which are developing software solutions that help companies to digitalize their production. Only our product line is around 1,500 people. We are serving aerospace and defense companies all over the world, start from the big, huge enterprises like Boeing, Lockheed Martin, Northrop Grumman, and down to smaller companies. I'm with the company for a little bit more than 20 years. Started my career being based out of Israel, started my career in the defense industry, was a project manager in the defense industry, and then moved to Siemens. I'm an engineer by education and looking forward for a great discussion today. Thank you.
Thanks a lot. Really appreciate your time. Now, I'm sure that Shai has a lot of interesting questions in his pocket for all the panelists, right?
Yeah.
I'm sure that audience may also have some interesting opinions, insights, or counter arguments from their own perspective and from their own experience. So I would request audience to also be very proactive. It's your platform. You can put anything in chat, any question, any insight. We will take your questions and insights whenever time allows. But yeah, I'll pass it on to Shai now for starting the panel. Shai, please go ahead.
Thank you, Pankaj. And I think I want maybe to start with a question that is relevant to all of you, which is, where do you see the biggest challenges of the aerospace and defense industry these days, especially in the manufacturing area, but not necessarily. So just a free discussion. Where do you see now the new challenges given all the changes we are going through? Yeah, General Levy, you want to start again?
Sure. I was waiting for somebody to sort of curate that and jump in. So
yeah.
There are a number of challenges, but I think probably two of the greatest ones is how do we, since we live in a highly globalized aerospace and defense economy, and that knowledge is very geographically distributed, how do we create a series of mutually beneficial intellectual property arrangements so that intellectual property created in various places accrues benefit to the places where all that's created? The way it tends to work now is often it gets aggregated in one or two or three places, as opposed to the distributed nature of today's intellectual economy and intellectual space. And I think that's a huge challenge, because really, if we want to create a better society and really and accrue the benefits of an emerging space economy, particularly, I think you can't have just one or two or three players be the predominant actors. There needs to be a sharing of that sort of intellectual property. So I think that construct, I think, is really going to be essential for us in a globalized, intellectually distributed sort of creative space. So, and then the second thing I think is as we move forward into a burgeoning space economy, how do we manage the raw materials and resources needed to create that space economy? And by that I mean the raw materials and resources that are here on the planet, obviously, and to make sure that there are collaborative uses there, but also as nations and industries look to do space manufacturing and space mining of various kinds, space resource extraction, if you will, coming to mutual agreements that benefits many, not just one or two. I think those are two challenges. And while maybe you were hoping I would say something very technical about, how do we create better rocket propulsion or something like that, I think these larger societal issues are far more intractable and really have a greater bearing on the outcome and success of our collaboration as humans, both on the planet and in space. So I'll stop there with those two large issues and see what my co-panelists have to say. Over.
Please. Zvika, do you want to say something about the challenges you see?
Yes, happy to contribute my part. Actually, when we are talking about the aerospace and defense industry, we are talking about a very diversified industry with different segments representing different needs. So it's a little bit challenging to point out a specific big challenge for the entire industry. I would say, let's take, for example, the commercial aviation or the commercial airplane manufacturers, to be more accurate. Being in the role of being responsible for the aerospace and defense market of our digital manufacturing solutions, I am meeting a lot of the aerospace and defense companies, and what I see very clearly is the rise of emerging countries to be global players. I'm talking about countries like China, India, and obviously they have a challenge to be able to deliver very complex products in top-notch quality, which could be used worldwide. On the other side, if we are looking at the biggest airplane manufacturers, let's take in this example Boeing and Airbus, obviously they realize that there is a big upcoming threat coming to them from the east, and they need to make sure that they are more efficient, that they deliver airplanes faster. These companies have a huge backlog of airplanes that they need to deliver, and they need to find creative ways to make sure that the production in Western countries like US, like the west of Europe, will still be competitive when comparing it to production in countries in the East, for example. And to do that, they will many times try to leverage all kinds of innovative concepts. We are seeing a lot the Industry 4.0 initiative, which is leveraged by aerospace and defense companies. And since we are here with SkillReal, I would say this is a good example of a company that delivers augmented reality solutions that help companies to shorten the learning curve, to train people and to make sure that there are no mistakes in the shop floor production, so right the first time. And this is why we in Siemens, we actually took SkillReal as a partner upon which we are basing our production augmented reality solution, which is called Assist AR. Thank you, Shai.
Thank you. Srinivasan, you want to add something to the challenges that we are seeing in the industry?
Sapar?
Sapar?
Yes. Yeah. Sorry. I agree with my colleagues. If we take the space industry as a part of the entire aerospace and the defense industry, and now we see that the space economy is emerging. So before we used to talk about space exploration, which includes exploring other planets like Moon, Mars, and remote planets. And we divided the commercial space. Now our commercial space is pushing its boundaries, and recently you may know that three big giant companies launching their ships, and they have a big vision. So in terms of these two big direction, there are a lot of challenges, like technological challenges, ecological challenges, political challenges. But if we talk the commercial space, there are also several challenges. For example, technological challenges, which means that there are new emerging companies coming to the market, and every company try to drop the cost of manufacturing, drop the cost of services, and as well as improving their services. And on the other hand, there are also challenges that we can talk about the space debris. You may know there are a lot of satellites in orbit, and their lifetime is limited, and it also can create like ecological challenge for the Earth. So yeah, that's all from my side. Thank you.
Thanks, Sapar. Professor Srinivasan?
Yeah, Pankaj. So I see the challenges in a way that the ecosystem is built between the man-machine interface. How do we develop that in terms of the shop floor control? And so the skill level required for a shop floor person to take up the challenges in terms of the application of the ML in these aspects as one of the key challenges. And as far as the economy is concerned, I think the Indian government is also in the digital civil aviation has reformed the several plans and measures they are taking right now to improve the economy aspects or the investments in terms of the aerospace and defense sector, and the indigenous development as well they are trying to do, and also the private public partnerships also they are trying to incorporate into this. And therefore I see the space industry, ISRO is also letting out some of the private partnership they are trying to take it up. So therefore that way it's a huge challenge in terms of building an ecosystem for to implementation of this. That's what I see. That's it. Over to you, Pankaj.
Thank you. So I just after talking a bit about the challenges, I wonder, where do you see growing innovation? Where do you see things that really grasp your attention and you think it's worth to share it? This is again a question to all. Where do you see things that you believe will generate significant change and significant ROI for the A&D industry in the next few years? Please, General Levy, you can start.
Okay, great. A couple of things, and I'll start with the broad overarching theme of advanced/additive manufacturing. Depending on where you are, it's commonly referred to a little bit differently. In fact, if you look over in the chat box, there are some comments there about particularly from Kako Lee about MRO operations and efficiencies. And when I think about MRO, what I think about is particularly the supply chains and the fragility of those, and the benefits that advanced and additive manufacturing can add to that. I think that's really where huge amounts of promise live, both for air-breathing vehicles and for things on orbit. I think the challenges will be for us to increase our ability in our engineering space and our product lifecycle management space to qualify additively manufactured parts for utilization. That right now, at least my observation, and not unrightfully so, it's a very slow, tedious process. And given the risks, it makes sense, that caution is the order of the day. But that said, it's a technology that will yield tremendous opportunities, the ability to manufacture more reliably and more quickly. I just think that our engineering spaces aren't quite where they need to be. The second thing that excites me, at least from a security perspective, is blockchain and the ability to secure supply chains and other bits of intellectual property, secure data. I'll just put it in that rubric, and that offers a lot of promise. I saw that Todd put in there about blockchains as a way to monetize IP. I don't disagree, but what I would say is before you get to that, you have to have an agreement on how you're going to slice the pie, if you will, when you're doing distributed creativity, if you will. So those are a couple areas that I think are promising. I would say I'll offer a counterweight to that. One area where I have some concerns that the benefits could be erased by this negative is our nation's and our global ability to produce the kind of science and technology leaders and thought leaders that are needed to manage and lead in these ecosystems, right? I think all of us would agree that our nations probably don't produce enough scientists, technology, engineer types of folks. And I think we all agree, I used to tell people here, particularly when I testified before Congress, how long does it take to make an engineer? And most people say, 3 or 4 years of university. I say, no, it takes about 21 years, right? Somebody has to have that baby has to grow up, go through primary school, et cetera, and have the sort of science and math background that gets that young woman or young man into university, who can then become an engineer and work in our collective economies. And so I think for us, the challenge or the parasitic drag on the airfoil, if you will, is our inability to produce the kinds of young men and women that our collective economies and nations are going to need in this burgeoning type of aerospace explosion that we see for the 21st century. So with that, I'll go on mute and let my colleagues reply.
Please, Sapar, do you want to add something?
Yes, if we talk about space industry, we generally talk about upstream and the downstream market. So in upstream markets, we talk about launcher satellite manufacturing. And if you see this upper stream is previously conducted only by the governments and the separate state. Now we see that there are a lot of emerging private companies who is really developing new technologies in manufacturing these space vehicles, including like using additive technology, using 3D modeling, and using composite material. And also we can observe a huge innovation in downstream markets where the space applications. So this downstream market is developing very quickly, a lot of innovations there, which implies, for example, machine learning, artificial intelligence. In particular, I can highlight the processing of Earth observation data using the artificial intelligence, and machine learning creates a lot of applications for different industries like agriculture, in defense industry, and so on. So yeah, these innovations is happening.
Zvika, thank you.
Yeah, I would say looking at the world from a production standpoint of the challenges in front of, or the challenges that aerospace and defense companies are facing with, I would say we're talking about, production people, a little bit more conservative. They want to make sure that they, what they use is a fully cooked solution. And, this kind of thinking actually created an industry which is lagging behind other industries in terms of new production methodologies. We see today the injection of new potential production methodologies. 3D printing was mentioned, the composite materials. Okay, we see something that was maybe 20 years ago, parts made out of composites, or an airframe made out of composite was a kind of almost a niche area. Today, we see that in modern airplanes, 50% of the fuselage is made out of composite materials, and this derives a lot of changes, a lot of innovation that is required. And I think really the aerospace and defense industry has a huge opportunity to catch up with a lot of promising technologies that are not highly utilized in this industry. Some of them are partially utilized in other industries, and therefore to make a kind of a frog leap and leading the production world. Whereas, today when you're looking at the aerospace industry, most of the production is I would say conservative, traditional. Add to this the fact that there is a lot of knowledge which is aging, a lot of people which are going to retire, and they hold a lot of knowledge. You need to make sure that you can digitalize this knowledge, and you need to make sure that you attract the young generation to work in these industries, as many times and in many countries, this industry does not seem something very fascinating for the young generation. So certainly an innovation is needed here, and the opportunities are out there.
Yeah, just to echo on what Zvika is saying, I think from our customer, thank you, Zvika, one of the things that really surprised me is two things. One is what Zvika said, is the worries about the skill gap, what they call, so the fact that a lot of knowledge is leaving the companies as people are going, the older people are going out of the workforce. And another thing is that I saw also here on the chat is the regulation. So when we asked our customers, what is the top benefit from our system, I was surprised to see that one of the top two is the ability that everything is traceable, that we take an image of each step, and if there is a problem, they can go back, identify the problem, and show to Yata or to their supplier that they actually found the problem. So this was one of the key benefits that we didn't think that this would be one of the major benefits. So this is about regulation and the way to help the companies to cope with the regulations and procedures. Yes, Pankaj?
No, I mean, these are fantastic points, but I also would love to include Kokho in the discussion, because I think he has many fantastic insights in the chat. So please unmute yourself, and why don't you introduce yourself and then probably speak up.
Hi, can you hear me?
Yeah, we can hear you.
Okay,
Please go ahead.
Okay, actually, I am mainly working on digitalization, and especially I have worked with quite a number of aerospace engines, these are blade manufacturing as well as engine assembly companies before. So that's why I feel that this is one of the issues that I face with many of them, is how to actually improve on the assembly efficiency, as well as improve on the MRO operation. I actually talked with a company like AirAsia and some Indonesian airlines before. They all have the same problem because of the regulation issue. They are almost running everything by manual. Even they try to use tablet to execute some of the checking, they find that it is almost not acceptable by the authorities. One of the major reasons is because they think that there are no experts they are behind them to help on this area. That's why I actually put up the comment to say that there's a lot more that we have to do in sharing the information. between the manufacturers and also the one who are running the MRO operations. So this is actually one major thing, right? Then the second part is because I also work in the digitalization on the shop floor for the Rolls-Royce before in Singapore. So I know that their operations has faced with a lot of limitation, especially on the assembly part. To assemble full drums, they have to arrange all the blade that has a certain frequency so that together they can actually ensure that the whole things will harmonize with each other. And the gap is also a very important part. That's why in this case, the insertion of the blade to minimize the gap, but at the same time cannot be too tight, right? So a lot of times they have to do this many, many times, even after they have simulated the blade sequence, okay? They still have to so-called like do a few times before they can get one full drum completed. So I find that actually just now some people mentioned about the 3D print. I find that especially in terms of the composite material, it might be a very interesting solution, not only for manufacturing the blade that fulfill a certain criteria or specification so that it can actually ease the assembly, right? But at the same time, in terms of repair. So when we actually fly the things and then the engine go for MRO, if they were to replace one damaged blade with the right blade that has the same frequency, almost is like very, very hard, almost impossible sometimes. But if they can make use of the composite printing and all this, right, then in this case, it will become a lot more easier because we can actually use the laser and all these things to fuse, to actually put additional material on top, and then you can create a plate that almost has the same kind of characteristic before. So I think these are actually a few areas that I feel is the technologies can help to improve the efficiency and the use of resources. Yeah, I think this is my just sharing
Thanks
some
a
of
lot.
my experience. Thank you.
Yeah, thanks a lot, Coco, for the detailed response. But yeah, let's also move on to Professor Srinivasan, and let's hear his insight on this question.
Yeah, Pankaj, as Coco was mentioning in terms of the integration to the shop floor process, I see the innovations can happen in terms of the integration of software solution like the CAE tools and the merging of the CAE, CAM tools with that of the digital twin platform. The merging aspects could be, the several algorithms and architectures development can be another useful thing, which can be realized more into innovative. That's what I see as the innovation.
Thanks a lot. Thanks a lot. Shai, what is the next burning question that you have?
So I think the next question, I would like to focus a bit on more specific technologies, and especially if you have, what is your view and where do you see the implementations of technologies like digital twin technologies, AR, and machine learning? You started to talk about machine learning, but where do you see the main benefits and ROI of these new technologies? Please, General Levy, let's start with you, as always.
Oh, well, I don't know about it as always, but I'm happy to dive in first. Golly, we could probably just do a couple hours on that alone. I think with let's go to maybe the very narrow segment of MRO. I think machine learning, AI and machine learning offers tremendous benefits in the MRO space, particularly for high precision machinery like jet engine inspection and repair. Most jet engine inspection repair today is still fairly manual, human being intensive. And I think that there's real promise there for advanced inspection technologies that could lead to advanced repair technologies to give us higher performance, higher time on wing, lower cost, but also something we don't typically talk about maybe in a lot of MRO forums, but I know I did as an operator, improved fuel efficiency. The better the jet engine is maintained, typically the better the fuel efficiency, the better operating margin for the airline, and then or the operator, as well as reduce potential carbon emissions. So I think those are some places where there are some real benefits. And then I would touch briefly on the digital twin piece of this. And I'm going to split the digital twin answer in two. One is for developing systems, and one is for what you and I might call legacy systems, or systems that are already in situ in the aerospace market. I look at it from, as you would expect as a retired military guy, from kind of the defense lens or the national security lens. And I look at a lot of the platforms that all of our countries tend to operate. We tend to operate or buy platforms and keep them for a really long time, right? And many of the not just airplanes, but a lot of things that our nations have bought were the pre-digital engineering era. And the longer you maintain something, the more fragile or shallow the supply chains become and the repair chains become. So I think for legacy systems, digital twinning and the ability to create digital twins out of platforms that were designed on basically graph paper and blueprints, I think that offers a lot of promise to extend the life of these platforms, as well as reduce the operating and sustainment costs, as well as create some supply chains that might have otherwise evaporated over time. I think so that's sort of just briefly in the legacy system, and that's not just for military things. That's for commercial aircraft and ground support equipment and a lot of other things, right? We tend to think about airplanes and satellites, but there's a lot more to those ecosystems than just the things with wings, as we like to say. The second piece, though, in the new emerging technology space would be digital twinning for new design and manufacture as a way to speed to market. I look at, for example, the collaboration between Boeing and Saab to create the new trainer airplane, the T-7. In essence, all digitally designed, and it's allowed that collaboration to produce hardware to market, if you will, infinitely quicker than historically we have done in the past. So I think those are really the opportunities that we see before us in those two spaces, kind of the AI ML as a way to enhance our MRO capability and capacity, and then digital twinning as a way to robust the sustainment and support of legacy platforms and the ecosystems that support them, as well as the ability to enhance speed to market and do a lot of design testing and reliability testing before we collectively start bending metal, if you will. So that's a lot of words, and I'm sure my fellow panelists will be able to unpack those ideas in great detail. So I'll yield the mic to them.
Thank you. Zvika, maybe you want to explain a bit more about digital twin, and where do you see the value and with your customers, and maybe some use cases that you saw that the digital twin really made a difference.
Yes, thanks, Shai. I would like also to build upon what General Levy said. Take, for example, let's talk about fighter airplanes. Take F-16, take F-35. You know that the F-16 was produced in a much higher rates compared to the F-35. Someone once told me, and this is not to disrespect any company, Lockheed Martin or whatever, someone once told me, we once knew how to build airplanes fast, but we lost this capability. So, it seems like that the production world did not fully, I'm talking about aerospace and defense, in this case, did not fully catch up with the advance in the design world, okay? With the new materials, new systems, a lot of computers on board, obviously. And I think this is where the innovation can play a significant role. We see now that the Department of Defense is pushing all the big American defense contractors to start and digitalize their business. And I think here, by the way, there is a bit of an advantage to the newcomers. Those big companies which are there for dozens of years, they have the legacy of a lot of old airplanes. If you take, for example, the B-52, someone once told me, I don't think you can talk to the designer of this airplane, which is still flying out there, okay? So if you have a newcomer, it can really start and use advanced methods, and we see it, for example, in all kinds of startups in the area of personal air mobility, for example, okay? A completely different thinking. And, I can ask the audience, do you think we will see the Tesla in the aerospace and defense market? Maybe you could say that SpaceX is the Tesla, but we can discuss that. But certainly, for example, take Shai, your solutions, SkillReal solutions, assist AR in the augmented reality area. Augmented reality by itself is out there. The technology is out there for a couple of years now. You know, my children were playing with augmented reality in their mobiles, I think 5-6 years ago already. Nevertheless, it was not embraced loudly by the production industries and specific by aerospace and defense industry. A huge opportunity to improve the shop floor production. Although I must say that there is still a difference between using it for games for children and using it for production. And when we started to implement our augmented reality solutions based on SkillReal technology, we actually realized, for example, that those glasses, someone mentioned the glasses, those glasses cannot be worn by a shop floor technician for a long time. After 30 minutes, it becomes dizzy, okay? So you need to make sure that the technology is ready for industrial usage, and certainly there is some way to go over there. But if the manufacturers will be bold and will try to test and to embrace these new capabilities and technologies, I think that there is, as I said, a huge opportunity out there, and the market is really hungry, to take all these technologies, the augmented reality, virtual reality, additive manufacturing, and use them in a more significant manner in the aerospace and defense industry.
Interestingly, General Levy has a comment on that, I guess. Please, General Levy, go ahead.
I thought I would try the raise your hand emoji and see how that worked. I absolutely agree with what my colleague just shared. I think that this whole line of conversation, though, is underpinned by something we haven't talked about yet, which is cybersecurity and cybersecurity technologies, right? So, we could say digital twin is the best thing in the world, but to the extent that it is or isn't secure in the cybersecurity arena, either offers tremendous benefit or conversely tremendous risk. And that sort of ties back to the IP conversation from earlier. So I just want to make sure that as we think about these advanced technologies, to include AI, ML, or IoT, the cyber pedigree of all of this is equally as essential as the technology itself. So that was just the point I wanted to make.
Thank you. Sapar, do you want to add something to the?
Yeah, couple of words maybe about digital twin technology. So if we talk about satellite manufacturing, the design phase is very important, and it's one of the major parts of the cost of satellite. And previously, using the classical approach, we used to develop the engineering model and test to do the environmental testing. But now, with the development of these new, let's say, digital twin technologies, the approach for designing of satellites changed, because we can create a digital twin and test it virtually, maybe to increase its efficiency and so on. If we talk about downstream segment, for example, now digital twin technologies is used to create the twins of the cities, the megapolis, so that, for example, the administration can analyze and make decisions. So these twins are developed using the Earth observation satellite data or UAV data. And it's just these technologies penetrating in our everyday life and changing the design and the decision making. So this is in a nutshell. Thank you.
Thank you, Sapar. Professor Srinivasan, do you want to add something to the regarding your view of digital twin and other technologies? So just maybe to add something to the digital twin, I think one of the surprises I have during the working with the industries, first of all, how much they like wires. When they see the camera is connected with wire, they make them feel comfortable. But of course, cybersecurity is far more than wires, and no doubt that this is a big challenge for sharing information and to actually implement new technologies. And having said that, I think the next question going forward is, okay, we have these great technologies of machine learning, AR, digital twins, and the question is, what are the barriers? What hold back the industry for embracing and using these technologies? And also, what do you think might be done in order to make this usage of new technologies easier for the industry? What are the main barriers? And if you have some vision about what will make it easier for them to use these new technologies, please. Maybe Sapar, we will start with you this time. Where do you see the challenges and the barriers?
Yeah, so maybe I will be very short. If we talk about the satellite manufacturing, so all our assembly lines are developed and constructed far before this technology came to market. So now it's maybe a challenge to modify this assembly line and integrate it the whole engineering system. So this would be one of the first challenge, I think. Yeah, but over the time when we use this technology, one day, yes, all this technology can be integrated and will be fully used in manufacturing area. In terms of application area, it's more easily to implement because it's less costs, let's say, and yeah, doesn't need much effort.
Thank you.
Thank you.
Zvika, do you have from your many Siemens customers, where do you see the main barriers? Because the benefits of digital twins and all this simulation is so clear. So what prevents the implementation from your experience?
I would highlight a couple of characteristics, Shai. First thing, I'll give you an example. You mentioned machine learning a couple of times in this call. And I spent a couple of days a few weeks ago, I spent a couple of days in one of the countries in Europe with the engineers of a business jet manufacturer. And looking at their daily work, you could really see that there is a place for a machine learning type of thing that will help them to save some of their work, because a good portion of the work is kind of a repetitive work. I mean, from a program to program, from one part of the airplane to another part of the airplane. I'm talking about planning the production of an airplane. So the potential is certainly there. Where are the barriers? First thing I would say that, as I mentioned, to put things in air, to make sure that it can, it can fly people, there is a lot of regulation in place, okay? And this regulation, including certification and other processes, make sure that every technology that is used is mature enough to be used in this type of industry. And not everything is, as I said, fully 100% sealed and mature. It needs to be mature. The problem is a bit of a chicken and an egg here, where the technologies might be mature for industrialization when they are when companies start to use them. It's a kind of a convergence process. Okay. Then I said there is some level of conservative thinking, which again is a characteristics of this industry. It's a mandatory thing in this industry, which I think will change as we see a workforce changing. And certainly I would say because of the explosion of data and the globalization today, which was mentioned earlier on, I think that a lot of companies realize today that even though that there are high barriers, there is no other way than start this journey. They are being pushed by the market, by the governments, and they are being pushed by the competition. So even though there are barriers, it is clear that the journey must start. It's not a nice to have journey, it's a mandatory journey nowadays.
Thank you, Zvika. Major General Levy, do you have any feedback on the barriers that you are familiar with?
Yeah, there are several, and I'm going to probably make them a little more simplistic in that because I see them, they're very horizontal. They apply to a variety of industries. One has to do with people, then one has to do with raw materials, right? I would say that for most of the planet, our educational systems are not geared towards the kind of advanced technologies that we need in our workforce. Somebody said earlier, in the aerospace industry, particularly, we have a kind of a graying or aging workforce, and there'll be a bit of a changing of the guard as the next generation starts to come in. The question is, have we trained them? Because my guess is their training structures, their educational systems looked a lot like their predecessors. Does that really serve us well? And I'll give you one great example and how this plugs directly into almost everything we're talking about here. At least in most of the Western educational systems, you go through primary and secondary school, and then you go to university, and you may get a bachelor degree of some sort, a baccalaureate, and then you come out and you're an engineer or a software engineer or a software developer. To be a high-end coder, does it really require a 4-year degree? Is that really the approach we need to take to produce the kinds of men and women that this particular industry set is going to need in the 21st century? I would say probably not. We could have a lot of conversation about that on another time. But my real point here is that I don't believe that our educational factories, right, that produce men and women, I don't think those factories are optimized for the kind of output that we need in the 21st century. So that's one point. Second point. We can talk about AI and machine learning and digital twinning and all of those sorts of things until we're all collectively blue in the face. That said, at the end of the day, all of these things require raw materials and natural resources to turn nothing into something, right? Whether it's composites, whether it's traditional bending of metal, whether it's making rocket fuel or doing MRO on some piece of equipment. And I think the way we compete for resources and the way we manage natural resources will continue to be a friction point for not only us intellectually, but economically, politically, and militarily, in an increasingly crowded planet with increasing globalization. I think that is a challenge that we face. So those are foundational issues that we collectively have a responsibility to try and solve before we can even start to layer on these other things on top of this cake, like AI, ML, blockchain, et cetera, et cetera. So I know that's a bit abstract, but I think it's an essential foundation. Those are essential foundational elements of continued success in this market space. Thanks.
Thank you. And just to reiterate on this, I think the main change, it's much easier to change machines than to change human beings. So it's a long process to let people understand and change the way they are doing things. Yes, Pankaj?
I believe Kokho's hand might be hurting. He has been raising hand for quite some time. So Kokho, please go ahead. I think you have some opinion. Thanks a lot, Sapar. See you later. Kokho, please unmute yourself. Yeah. Go ahead.
Actually, on the part on this technology adoption for our problems, we have some industries discussion before on this area for the aerospace and defense industry. So 3 of the problems are highlighted as potential obstacles, right? The number 1 is the data, okay, the information itself, right? Currently, the way the informations are made available are very, very secretive and difficult, okay? So because of the various regulation, right, the dissemination of information is very difficult amongst people who are collaborating for improvement, right? So we feel that instead of talking about sharing of data, maybe it is better to share the services. That means we are talking about using something like a federated data network, where we talk about, okay, whoever who actually wants some information, instead of I send you the data, maybe you send me the service, right? And I can evaluate your service, and then after that, let your service run my database, get some information, and then after that, inspect on the information and send it out. So that means we should actually consider reverse the way of how data are being shared right now, right? Currently, a lot of the standard is if you need the data, you expect the data generator to send out the data, and then you need to have a lot of clearing, right? But if we do opposite way, okay? For example, when we talk about evaluating the engine weakness, so based on the information generated from the airlines, they can actually stack all this information and analyze where is the potential weakness on the component. But the key is this information should not be shared out to the designer easily, but rather they can actually let you run the program inside and identify the weakness, and then only just report this weakness. And then based on that, you can collect the statistic. So this is actually one of the idea, right? Then the next problems that we see is there is no standard process across the many of the aerospace participants, right? A lot of them is they actually run their own process. When people are not familiar with the concept of, for example, the Lean, Six Sigma, this kind of concept, so everybody will try to run in a suboptimal way. So I believe this is one of the problems that we see. Last time we have a big program to run a Lean Six Sigma program within a very big European organization on the defense for like 10 years period, right? Why? Because they actually identified this as one of the key reasons why they cannot work in a very efficient way. So they need to find a way to synchronize the process. I think this is another problem that actually prevent the adoption of technology. Without the process, the adoption of technology will be very, very suboptimal. I think this is another things that we concluded during the meeting. Thank you.
Thanks a lot, Hugo. I think Janet also has some interesting questions. Janet?
Yes, I'm here.
Yeah,
I was hearing all your opinions about manufacturing, additive manufacturing, and satellites and all these improvements. And I agree. Like there has been a lot of improvements in the area of manufacturing and assembly. But I work many years for MROs, and I can see that there is a huge opportunity for improve the way that we handle the data. Is there, in your opinion, is there a blockchain can provide this transparency and traceability to the MRO data?
I think somebody needs to. Okay, we are on an hour now, right? I don't know who can stay and who will have to leave, but I'm sure that we can have a discussion on this topic for hours and hours, right? Shai, did you want to continue, or do you want to stop at 1 hour? What do you want to do?
I think just for for the honor of the time of the panelists, we can stay a few more minutes informally, even without recording, just to share some information. But I think other than that, we should move forward, all of us, and go back to our work. So whoever wants to stay is invited to stay and ask more questions. Whoever wants to leave is can, of course, invited to leave and move forward.
I know General Levy has to leave. So thanks a lot, General Levy, for joining and offering your
Thank
insight.
you.
Really appreciate it. Okay, Todd has something to add. Probably Todd and then Selva.
Hi there. So I just thought I would comment on the MRO question. I can say something about that because I'm the founder of a company called Block Aero. So we actually have already run some projects with like Rolls-Royce, Singapore Airlines, EthAum, pretty much exactly on this question that you're posing, which is, can you use blockchain to maintain the consistency of the transaction, which could be like a MRO, an engine overhaul, or a component shop visit, things like that, where you have several players involved. You have like the airline, you have the OEM who may be managing those assets under a power-by-hour contract. You have different overhaul shop and component shop vendors. And everybody is kind of coming together to look at this data and reconcile it between them throughout like a multi-month time period. So what we found is you can use a blockchain system to, and this is what we essentially do, is we create for every part, every aircraft engine component, a kind of unique passport to link all of the records that you would consider like a release certificate or certificate conformity or an installation removal record. All these things can be digitalized. And instead of sending like an email with an Excel or a link to a cloud where you're sharing some PDFs about the configuration, things like that, all of this can be synchronized using smart contracts and we go with the private blockchain approach, but I think you can do the same or similar with a public chain, but then you have the problem of data privacy. So you can do this more efficiently in terms of speed with consortiums that have each have their own access to a distributed ledger. And I would say that the main barrier to this is bureaucratic and people, as the general said earlier. So it's about overcoming the obstacles to introduce new systems, and it has to be something that an entire consortium or ecosystem are ready in some way to participate in. And then they will be bringing questions about, well, how do I integrate the data from my existing system? And these are things that take a lot of time and are challenging to overcome for any new technology being introduced. Over.
Thanks a lot, Todd. And I see people are leaving for other meetings and work. But yeah, again, thanks a lot for your time, for your participation. Really loved it, and I'm sure this is not the only call, not the only meeting where we are meeting. There'll be a bunch of other sessions where we will be talking to you, and I would love to reconnect with you in more sort of casual setting. And we have Shai on the call. Again, please feel free to connect with me or Shai if you wanna discuss more about EthAum Venture Partners or SkillReal, and we'll love to have that discussion with you. Okay. Anything else, Shai, that you wanna add here? Probably we should drop our email ID so that people can connect with you and I later.
Just to thank everyone for the participation, and I will just put in the chat my email so anyone that is interested can contact me and continue the communication. And just again, thank you, Pankaj, for hosting us. Thank you for the panelists, and thank you for the participants. And have a nice day.
Thank you, everybody, and we'll talk to you soon. Take care, stay safe.